So just say, go to lead code, say lead code concurrency. You can also go. That's it. Just say that. Concurrency problems, lead code. Okay. Concurrency, these are the problems. Okay, I think I had briefly alluded to these problems in the last class. We just looked at them. So today we'll get ahead and do them, because if you're able to do this only, then you have understood threads. So we will start with the first one. I don't know this one or the print in order. That is problem number 1114. Just click on it. Talk about the question, because I've seen it once. You are supposed to create 3 threads. Yes. Now, every time if you read the question in detail, you will realize, if you go down the question, have all of you read the question? If not, I'll wait. Read the question. You have to get used to reading it. Okay, I'll wait. Please read the question completely. Presuming everybody has read the problem. Now, there are 3 threads given. Can you see that? You have to create 3 threads. And the order in which the threads have to be created also will change. Sometimes it will be 1, 2, 3. Sometimes it will be 3 to 1. Sometimes it will be 2, 3, 1. Whatever. So all possible permutations of 1, 2, 3, it is that in which the threads will be created, in that permutation. Now you also, this is one fact. Fact number 2 is that each thread should do only one thing. First thread prints first, second thread prints second, third thread prints third. That is also clear. That is fact number 2. Now, fact number 3 is that while each thread prints its own text, the order, irrespective of which order the threads are started, independent of that, final order should only be 1, 2, 3, or I think it's called first, second, third. That is the order in which it, even if I start the third thread first, or whatever order I start, I should always get the output as 1 first, second, third. That is the requirement of the question. You think how you will do this problem, and then we will solve it first on, we'll open a practice question. You try to solve it, then we'll solve it. Okay, so looking at the question in more detail, you also have the question. There is a class foo which is given to 3 threads, and each thread has to say, first thread has to say first, second, third in the specified order. Now the order will be given like this. The question gives the order. You see, number 1, example 1, the order in which the threads are started are 1, 2, 3. Then the answer comes first, second, third. Second time, can you scroll down? The order in which they are started is again changed. It is 1, 3, 2. Again it should print first, second, third only. Whatever order in which the threads are started and run, whatever the order, answer should always come first, second, third. This is mandatory. Okay? So, which means we have to do our synchronization mechanism, we have to do our wait notify mechanism, and all of that. Okay? So how are we going to design this solution? How are we going to write this? So how many threads do we need in this program? 3. We need 3 threads. I think there is no doubt. The question itself is asking you to create 3 threads. Okay. Now let's discuss each thread. Should it have the same body or should it have a different body? What do I mean? Should every thread do the same thing or a different thing? different. What is the different? First thread should only print first. Second thread should print second. Third thread should print third. Now, the main object, you see there is one class. What is the name of the class? Foo. The class foo. Now, here comes the important point. How many instances of class foo should I create? 1, 2 or 3? How many instances, you know what is instance, right? How many objects of class foo should I create? 1, 2 or 3? 1. This is the important part. I should create only one instance of foo, so the methods are called on the same object, but the methods, the threads should do first, second, third, but they should always come in that order irrespective of how the threads are started. So what does it mean? That we should use a flag mechanism to ensure that the threads, whichever order they are started, always come first, second, third output. Okay. So, okay, let me put it a little tricky question. How many values should flag take? 3. 0, 1, 2 or 1, 2, 3, whatever. You can start with 1. If the first thread finishes, it turns the flag to 2, and when 2 finishes, flag 3. Irrespective of whichever order they are called, they will go in the same sequence. Okay. Now, we are going to open a practice question. So there are going to be 3 threads, first, second and third. Okay. These are the 3 threads. So I am going to create 3 runnables. So what should we call the runnables? Let's call this runnable as F runnable, okay, S runnable and T runnable. Okay, now I am going to create, since this is the first time we are doing it, one runnable for you. Okay, the first runnable I am going to create. Okay, so I am going to create the first runnable. Just watch. Class class F runnable. Class F runnable implements runnable interface. Okay. And okay, implements runnable interface. The runnable interface consists of which method? Public void run. That is a method it consists of. So this is the, we have to write the body of this method. But before we do that, okay, I'll come back to this page. Before we do that, I need a constructor for runnable. So in the class runnable, I'll create a constructor. So foo F. So the runnable takes foo object, the F runnable, all runnables will take foo object as a parameter, and it will have a foo object as a parameter also. So let's call this F1 and let's call this F. So it will say F is equal to F1. So it will initialize the F object which is there in the class to F1 via the constructor. So this is what the constructor will do. Now once the constructor does this, okay, then I will go back to the previous page. So I have with me foo F, which has been initialized as I just showed you. Okay, let me write it again. Let me write the whole class. Class F runnable implements runnable. I'm writing it all over again. And then we have one data member here called foo, whose type is f, and I have a constructor. The constructor name obviously is called fRunnable. It takes another parameter f1 and initializes f equal to f1. So it has received a foo object in the constructor. Now, having got this, now we'll write the run method, public void run. So I am writing the run method. Now, what should the run method do? Okay. This is important to understand. Now, please remember that though fRunnable is, we are using it as to call the first method, it may not be called in the right order. It may be called first time, second time, third time. So, for this thread to run, it has to have a method, okay, called first, that method first. Now, the first method, while it is going on, second shouldn't go on, third shouldn't go on. So, in the class foo, we'll have to make a small change. We'll have to make each of the methods synchronized. So let me change class foo also little bit so that you are clear what foo should do. So class foo looks like something like this. So it has a method print first. So print first, which does SOP first, the string first. So it's going to print this string first. Now this method, while it is going on, I don't want any other method to be called on foo, which is print second is another method. So SOP on that is second, and print third is another method, and the SOP on that is third. So each of these methods must carry the word synchronized. This should be synchronized, this should be synchronized, and this should be synchronized. Now you'll ask, why? Why should each method be synchronized? Obviously, while first is going on, second should go on, and while second is going on, nothing else should go on. I mean, each should be mutually exclusive. To make methods mutually exclusive in Java, that is when one is going on, the other shouldn't go on, we have to lock this object. So which object gets locked? Foo gets locked whenever any of these methods get called. So if the first thread calls print first, then it should lock this foo object and not release it till the first printing is over. Now you'll ask, first printing, how long will it take? Whatever it takes. It may be just a single method. Later, it may be a more complicated method. Whatever it is, when first method is going on, print first is happening, nobody else should come. So we will mark it as synchronized. So it will lock this object. So if the second thread calls this, then this won't happen. So this is the change you have to do to class foo. Okay. Now going back, let me do previous. Okay. Now let's start. So I have implemented, I have changed the foo class to have all synchronized method. Now in the run method, for fRunnable, what should happen? So I should check whether the flag is 1. Okay? Let's say flag starts at 1. So flag should be a variable which should be shared again. So where should flag be? Who is the shared object? The shared object is foo. So flag also should be a variable in foo. So let me go back to next page. Yeah. So here I have to add another variable called flag, int flag. I'll set it first to 1 because I'm going to do 1, 2, 3. So I'm going to set flag equal to 1. Okay, now I'll go previous again. So flag is equal to 1. Then, now I go back. So I have the flag variable in foo. So this method should not run until, so while flag not equal to 1. For this first guy, if the flag is not equal to 1, now the flag is where? In F. So I should say while F dot flag not equal to 1, what should I do? I should wait. I'll explain all this, but I'm just giving you a gist. While F dot flag not equal to 1, wait. I should just suspend, because for me, until flag becomes 1, I should not do anything. So if flag is not equal to 1, I'll wait. I'll not do anything. Now, if let's say flag has become 1, that means then only the control will come here. What will I do? I will now say, I'll call that method f dot print first. Okay, I'll call that method. That means flag has become 1. If flag has not been 1, I'll be in wait. Okay, so I'll do f dot print first. Then I'll hand over the baton to the second thread. I'll say f dot flag equal to 2. Why am I saying f dot flag equal to 2? Because now I want the second thread to do the work. So he'll be waiting for, if flag not equal to 2, wait. That is what the second thread will be doing. So I am saying f dot flag equal to 2, and then I will notify. Okay. Now I can't do a notify here. These two methods, wait and all this, I think all this code should go into, okay, all this code, if I put it here, I'll have to make run synchronized. So I should be doing this, but I should not be putting this code here. So I should shift this code to print first. So what this run method, instead of doing all this here, I should say just print first, and in print first I should do all this, because that is a shared object. So I should not put code here. I should go to next. This is next, no? Yeah. So I should change this print first to something more. Okay. So let me write this print first again. Again I'll write print first. So synchronized. Then we'll write it, don't worry. This I'm just explaining first. Print first. Okay. What should it do? It should wait for flag while flag. Now flag is a variable here, so I don't have to do anything. So flag equal to, not equal to 1, wait. Remember, wait can be called only in a synchronized method. That's why I put the code here. Then I make flag equal to 2. Okay. Then I have to do print. I call the second guy. So I can say flag equal to 2. Now just making flag equal to 2, and I think that should be enough. If I make the flag 2 and I make notify, And of course, I have to say print first, so that printing has to be done, SOP first. Yeah. So this is the code I have to write. Okay. Now I have given you a gist of the code, but now I'll show you how to write the code, right, starting from scratch. So those of you who have not followed so far, those of you who have followed, continue. Those of you who are still not following, I am doing it again so that you can clearly see the code. Okay, I am going to show the code here also. Initial days in Threads take time because it's not easy to understand the way the synchronization happens. But I need the code here so that we can play with it. Let's start writing. So as usual, we'll import java.util.star just to be, because I think runnable is in java.lang, no? Okay, we'll import it, we may need it. So first we'll create the shared object, which is what this example asks, which is foo. So see the way we'll create class foo. Okay, so class foo starts like this, little bigger font I think. Class foo, yeah, this is fine. Now it has three methods if you see the question: print first, print second, print third. Now we are going to write the body of the methods. So we are going to create first of all a flag variable in foo. So we are going to say int flag equal to 1 to start with. Then we are going to write three methods: print first, print second, print third. Each method is synchronized. So this is how it goes. So synchronized, synchronized, print first, print first, FIRST, print first, and it will take no parameter. So it will wait, in case flag is not 1, it will wait for flag to become 1 so that it can do its work. So while flag not equal to 1, while flag not equal to 1, not equal to 1, what it should do? It should wait. If the flag is not 1, it will wait. So it is waiting. Now close the flower bracket. Yeah. So while flag not equal to 1, wait. So if I reach line 8, what does it mean? That flag is 1. Okay? Otherwise it won't reach line 8 at all. If it is not equal to 1, it will keep waiting. So if it has reached line 8, it means it is out of wait. That means flag is 1. Flag is 1 means what? This thread or this method should run. The thread which is running this method should get action, correct? So now we'll say while flag equal to 1, not equal to 1, wait. Fact is flag has become 1. Now it should do an SOP, system.out.println. System.out.println. I'll now say print first, means first. It will just put first. Okay. And then it will say flag equal to 2. So now the second thread will get an opportunity to run. See how it works. Each of these will be given to 3 threads. They will call different methods. So flag equal to 2, and I will notify whoever is waiting on this object, I will notify them. So I will say notify. Done. So this is what class foo does. Okay, now how many methods should foo have? 3. Print first, print second, print third. Now, can you think how to write print second? This is print first. You can close the method, notify and close the method. Okay, so that is the method. Now, I'll call a method called print second, synchronized, print second. Okay, we have copied it, but we have to change it. So, what should be the starting condition for second? When should I print second? When flag is 2. So, until flag is 2, what should second do? Wait. So, I should say in second, print second, while flag not equal to 2, wait. Okay. Then I will say system.out.println, come down. System.out.println, yeah, you can borrow that line. So system.out.println second. Okay. Yeah. So then we will say flag equal to, what should we say? After second has been done, what should I say? Now I should give the chance to third, correct? So I should say flag equal to 3 and notify. Notify is to alert whoever is waiting. They need to get alerted to that they should now do their work. So they should come out of wait state. Whoever are waiting for flag equal to 3, which is in this case the third thread. So now we have print first, print second and print third. Print second is ending, go down. So print second is ending there, on 19. Now we have to write synchronized print third. If you scroll up a little, or just copy the whole method, you can copy the whole method and put it there. Yeah. So we say print third. Yeah. So if I say print third, while flag not equal to 3, wait. Okay. Print line, println third. Wait. Now what should happen? See, how many times do we want to print first, second, third in this problem? Only once. Yes? So after third is printed, what should happen to flag? I should either cancel the flag. That means I can make flag equal to 0. Because nobody is waiting for equal to 0. First guy is waiting for flag to become 1, which is 1 initially. Second guy is for flag equal to 2. Third thread is going to be flag equal to 3. So nobody is going to wait for flag equal to, after third, we can make flag equal to 0. Okay, on line 26. Okay, so let's see this class again. So this is the code. Initially flag is 1, then we are having print first, then we are having print second, then we are having print third, all of that. Then we are having for each one some conditions, which is the flag should be 1, the flag should be 2, like that. And till the flag is at the right point, we are waiting. Okay, now we'll write our main. So go down. We'll have to write the test. Okay, we'll write our own main class. This class should end. Just move the bracket up a bit. Saved. Okay. So we will now write our driver class. test class, main, come down, public, class test, then we'll write and then show. Okay. So class test will have the public static void main. Oh, sorry, before that, okay, I forgot one step before this. We have to create the runnables. Then we'll create the test. So let me create 3 runnables. One which does print first, print second, print third. 3 runnables, because each thread is going to do different activities and each will need the foo. Okay, so there's going to be a lot of work. So can we go up? No, before we create class test, let's create outside of foo class. We'll create class, let's call it runnable first. Class runnable first. Runnable first. Okay, so it's going to create a runnable. So class runnable first implements runnable interface. Implements runnable interface. It also has a constructor which I'll use to pass the foo object. So class runnable first implements runnable. So it has a variable foo f. Yeah. On that, that foo f is passed as a parameter in the constructor. So runnable first. Yeah, so we'll show it here and then we can copy it there. No? So class runnable first implements runnable, then we will say you please do it in telescope only so that you can run. Then it is having a parameter or an instance variable foo f. Now we'll create its constructor runnable first. So that is the constructor. Name of the constructor same as the name of the class. Runnable first. Then it should take a parameter. Foo f1, and it should assign f is equal to f1. I have done that. So my runnable construction is over. Close the bracket. Close. Now, what is the run method of the, since it's a runnable, it ought to have a run method. So what should the run method do? Let's write the run method. Public void run. And in the body of the run method, what I'll do? On the shared object foo, which is a shared object, I will call that method which we just wrote called print first. So I will say here f dot print first. That same runnable, I will call the method print first. This is the job of the first runnable. That's it. Because everything else I have shifted to print first. Now, I'll create another runnable second. Now close this runnable. Yeah. Now runnable second will be almost a ditto copy of runnable first. What will be different? You will see. Okay, we are creating the runnable second. So this is going to become runnable second. It also is going to work on the same foo object which is passed to it as a parameter, and in the run method of runnable second it is going to call, on the run method it is going to call print second, the second method of the shared object, which is when it is called the others don't get called. So that is the run method. Now we are going to create runnable third, which is going to print third. So class runnable third implements runnable, and it has a runnable third, and it says in its body print third. Done. Okay. So we have now 3 runnables in our program. Now let's summarize what we have done before we start writing the final class. I am hoping that some of you will understand. I am not hoping all of you will understand. I don't want all of you to understand. Okay. Now see the way we have done. The shared object which is given to all 3 threads is what? Foo. That is what I am going to pass to all 3 threads. So this foo, this is the shared object, has 3 very important methods: print first, print second, print third. And what do these methods do? Can you go up? Look at each method. They are more or less similar to one another. Flag is equal to 1. So first time the object is created, flag will be 1. And once this thread is started, which does the runnable 1, first runnable, what it will do? It will try to call the run method. Now the run method of the first thread, what it will do? It will say print first. Now if it calls print first, what should it do? Remember, the signal for print first is flag should be 1, otherwise print first will not do anything. It will just wait. So look at that condition. While flag not equal to 1, print first is going to just wait. If flag is 1, which will be 1 first time, what will it do? It will display the string first and it will set the flag to 2, and it will notify all waiting threads. Now I am done, you guys wake up and do your work. So who may wake up? 3 may wake up or 2 may wake up. Let's say 3 wakes up. So what will thread 3 do? It will try to call print third. But if it calls print third, remember, print third can't do anything till flag is 3. If flag is not equal to 3, even though third thread is called first, what will happen? It will wait. It can't do anything. That is what we have written. So irrespective of which order the Java scheduler calls the threads, they are going to follow their own discipline. They are going to say, I will not do work till the flag is at a particular value. Only if the flag is at a particular value, I will do my work. And if it is not in the particular value, I will wait. And let other threads do their work. When I wait, I release the CPU to the other threads. Let them do their work. Till the situation is ideal for me, till the flag is at a particular value for me, I will not do the work. Because otherwise it will disturb the order. Okay, now let's go and do the final thing, which is write the main class. Okay, now you will understand the whole thing coming together. Okay, now I think one bracket is extra. Class test, above class test. One closing bracket, that may not be needed. Okay. So now class test. Okay. First what I'll do? I'll create foo, instance of foo, which has to be passed to 3 runnables. Foo f is equal to, first time I am creating foo object, new foo. I created it. Then what will I do with that foo object? That foo object I have to pass to 3 runnables. Now I will create each runnable. Let's call them, I don't know what are their names again. Let's go up. Runnable first, runnable second, runnable third. We'll create R1, R2, R3 instances of these. Okay. So runnable first, yeah. Please align it. Runnable first, let's call it R1 is equal to new runnable first. And to that I will pass an object called F, right? The runnable object F. Okay. Now, similarly, I'll create the second runnable. I'll create the third runnable. Okay. Runnable second line now. Runnable second R2 is equal to new runnable second. And same F is created only once. Okay. Then R3, runnable third, yes. R3, new runnable third. Okay. The three runnables are also ready. Three runnables are there. Okay. Now we have the three runnables. Now we are reaching a point where what is given in the question starts making sense. If you look at the question again in lead code, what is he saying? He is saying, I will start the threads in different orders. Sometimes 1, 2, 3, sometimes 1, 3, 1 3 2, sometimes some other order. I have option to call the threads, start the threads in whichever order you want. My output should be same. It should always be first, second, third. Whatever I call threads, you don't care. You should be managing your synchronization in such a way that the output should not change. The output, whichever order I call the threads, the output should always be first, second, third. I don't care which order we call. So what we can do now, in the question, he is giving the order. So we can read the order or we can skip that step and decide the order. Okay, since we are not doing it on lead code, we will take the order but not read the order. So otherwise you will have to do 3 scans. You should say what is the first number, what is the second number, what is the third number, and depending on that you should write a switch case to call a appropriate thread. So I am just skipping that because that is not relevant to the code. We will change the order. So first time what is the order? 1, 2, 3, correct? Then we will change the order, but output should stay exactly same. Okay, so first time you see the order is 1, 2, 3. We will play with the orders. So we will come to the code. Now before that, let's just change the order. So we will say first, we will create the threads now and then start them in the appropriate order. First let me create the threads. So thread T1 is equal to new thread. This is how you create a thread. New thread R1. Okay. Now thread T2 is equal to new thread R2. Thread T3 is equal to new thread R3. So we are creating the 3 threads R1, R2, R3 which are called T1, T2, T3 with those runnables. Okay. Now the starting order, we will try different starting orders as given by the program. First time it is what? 1, 2, 3. So we will say T1 dot start, T2 dot start, T3 dot start. T3 dot start. Okay. So this is to protect the first question, first case, first case. Okay. Now we will take the whole code, put it in telescope and try to run it. Let's see what order we get. Okay. We are into telescope. Hopefully you also have this code and we'll try and compile it. Save it. Okay. Rocket. Run it. Okay, let's see if there are any compilation issues. It's a fairly big program. Maybe I am thinking one extra bracket again. Maybe extra. Okay, let's check. Print first. Acha, return type void. We didn't give the return type for these methods. It's not returning anything. So we'll have to mark them as void. Void. And then third one also. The print first, second, third, we had not marked the return type. So we save it again and try to run. Wait and notify, they throw uninterrupted exception. So we have to, they are checked exceptions, so we have to report them. So what will we do? We will say throws interrupted exception, or we can catch it also. Let's try this. Oh, I think it is better to catch, because again when we call, it will create trouble. So we'll put a try catch block in print first. After the, you can write the whole code in that, no? Try. And after notify. Then we'll put a catch after notify. Catch interrupted exception. Interrupted exception. Okay. Don't write any body. You can skip that. Empty body. Without. Now you will have to do that for print second also. No. Catch block ended there. One extra, I think. Catch block ended there, and the method ends on. Method ends on 60. Correct. So here also we'll have to put try catch interrupted exception. Method ends. Good. Then again you'll have to put for third the try and the try, no, I think one extra. Full class ends there. Correct. Okay. So let's try saving it. Oh, there is extra bracket. Try now. Yeah. So finally, it's a big program, but see the order. It is first, second, third. Now, before I go through the program again and explain, I'll change the order in which we are starting. And if we are doing it correctly, even if we change the order in which we are starting, I should always get first, second, third. It should not change. That is the beauty of synchronization. Okay, let's go to our code and change it. Change it in main. So now this is the order in which we are starting. We will try any permutation of that. Let's try one or two permutations of it. So let's try 1, 3, 2. Even if I do 1, 3, 2, my answer should be first, second, third. Then only I am doing threading correctly. So let's try this and check whether our synchronization is working correctly or not. So now we have changed the order of the threads in which they are starting. Now it is T1, T3, T2. It has changed. Let's see what we get. Okay, we are running it again. Adi save chesara. Okay. Again the order stays exactly same as it should. First, second, third. let's change the order one more time or couple of more times. Let's change it to, come down, in main. Okay, let's say 3, 2, 1, exact ulta. Okay. So 3, 2, 1. Okay. Now, if I say 3, 2, 1, whatever I say, it should always come first, second, third, no matter. Only first wants to come. Huh? No, I think okay. Let's run it again. I think it got blocked at that point. Okay. The order you should also get first, second, third again. Are you guys getting it? No. Anyone was able to complete? No? Exactly. You are getting the same output. You should change the order, whichever order, whatever order you get, please try and change the order. You should get same. You should always get first, second, third. Then only the program is correct. Otherwise, our program is having gadbad. Okay. Okay. Now I will change it one more time and then we will go to the program again. Just to, and because you have to do with me at least 4 or 5 this kind of questions, then only we will move on to next topic. Because these topics are very crucial. This one, the next one where we do collections, and the next one where we do JDBC and collections together. So we'll change the order. Now it is 3, 1, 2. Some other order. Any permutation you try, I should get the same answer. Okay. The thing stays consistent. Now, what is happening and how is it happening? Okay. Now, what I think I should do for you is, can we give them this code? Okay. So, we will save it in program thread 1. We'll save it in a moment. And understand. I'll wait few minutes. Understand. Please, it is very crucial that you understand. If you stop and start again, I think you will get our code in the same thread 1 which you have edited. Or take our thread 1. We'll try and get you that program either in that or some other thread. Please look at it. If you have got that program, please read through the program because you have to do at least 3 or 4 of these. I am going to start doing one more. But first read this. Understand what's going on. If you don't understand this, you can't do the next. I will, if you have the program with you, I'll walk you through the program once, very quickly. So, this is the structure of our program. See, the thing is, you have to understand one very important thing, which is foo. Foo is the shared object. Okay. So, in foo, what are we using? For synchronization purpose, we are using that flag variable, flag 1. That flag in OS, I would have called it a semaphore. Okay. Here I call it just a flag or a variable used for synchronization. Are you understanding the role being played by flag? The flag is deciding who is the next guy. That is like a token. He is passing the token and it is deciding based on the token I will get called or I will do work or I will not do work. So for the first thread to do work, now first understand what work first thread has to do. You have to look at its run method. Run method has only one call, print first. First thread will do only print first. Second thread will do print second. Look at your code. Third thread will do print third. Look at the runnable run method. Each runnable which is being done by the thread has only one method, which is run. And that run method is besides the constructor, which is used to pass the shared foo object. And then each run method is doing what? The run method is calling print first, print second, print third, depending on its first runnable, second runnable, third runnable. What is print first doing? Print first is waiting for flag to become 1. If flag is not 1, print first will say, I will not do anything, I will wait. And because wait method throws an exception, we have the try catch block. It's a declared exception. So I have the try catch block. Okay? And therefore, similarly I have print second, print third. And then I have the runnables which are in the run method, calling this run method. Calling this print first, print second, print third. And also getting the runnable object, the shared object foo, on which the methods are getting called. The rest of the main method is very trivial. It is first creating the 3 runnables, then it is creating the thread from the runnables, and then it is starting the thread individually, each thread, one by one. That is all the code is doing. Okay? So, if you have got that code, now let us try to be a little more adventurous, okay, and go to another question. Lead code. Now go back. Okay, again go to concurrency. Concurrency. Now let's look at the next question in concurrency. Scroll down. Next question is 1115. Okay. So it prints foo bar alternately. Foo bar alternately. First it prints foo, then it prints bar. Okay. Now here is a, let's see. Now it's a condition. You have to alter previous code only, what I gave you. I have given you code. What I want you to do is, there are there is a class, something like this, foo, which prints foo 10 times, and bar, which prints bar 10 times. See this, something like that. There is a foo method in foo method, and then there is a bar method. Foo bar, first thread, okay, imagine, I'll rephrase the question for you. Imagine there are 2 threads in the program, okay. One thread has to print foo 10 times, other thread prints bar 10 times. But, the output should be what? Foo bar, foo bar. The foo will run 10 times in a loop like what he has shown. In the lead code question, foo will be called 10 times. Now, that means there should be a loop in the first thread which should call the foo method on the shared object, foo bar. Foo method will be called 10 times. Bar method will be called 10 times by another thread in the run method. But the shared object should be managed in such a way that foo, if it is called, flag should be 1, and only if flag is 1, foo should be printed. If flag is not 1, foo should not do. It should wait. Flag is 2, bar should get called, and if bar is going on, foo shouldn't go on, foo is going on, bar shouldn't go on. So you should have in the runnable class, just imagine in the runnable class on the shared object, whatever you want to call it. So, okay, let me say this again. The shared object, let's call it foo bar. In the runnable, first runnable for the first thread, that foo bar object, which is a shared object, the first runnable calls foo method on the foo bar object 10 times in a loop. It says foo bar dot foo. And what does the second thread do? On the foo bar object, it says foo bar dot bar 10 times. Okay, I'll give you the runnable because I think that will make life easier. Okay. So use my runables only. So there is going to be an object called foo bar. Foo bar. This is going to be passed to two threads. Each thread is going to have its own runnable. So let's call this runnable as foo runnable, and this is bar runnable. So on the shared object which is passed to both the runnables, that means to both the threads, what will this do? This will say for int I equal to 0, I less than 10, I plus plus, this runnable on this foo bar object, let us call this FB dot foo, it will call. What will this runnable do? For int I equal to 0, I less than 10, so on, it will say on the same foo bar object which is passed to this also, it will say bar 10 times like this way, but the output should be foo bar, or whatever. It can be in different lines also, but the output should come like foo bar with space. Okay. You can print on same line or different lines. I don't care. Now you have to do this because I don't want you to copy code from the lead code. You do this by adapting my solution, what I just gave you. Just try and adapt my solution, and you will have to reduce it to 2 runnables because the example that I gave you is 3 runnables. Now you need only 2 runnables, 2 threads. Set it up in such a way and tell me if you are done. Foo bar, it should print. Remember, the runnable should take FB, the shared object, as a parameter, just like it was taking foo. Now it should take foo bar as a shared object. Foo bar has the shared object. It has 2 methods, foo and bar. Foo method and bar method. Each of the runnable will call the foo method 10 times. The other runnable will call bar 10 times. But the output I should see is foo bar 10 times. Foo bar in that order. Okay. Here you should understand the question also. Just make the runnables bigger. You have to create the foo bar object cleverly. That's all. After that the code is straightforward. Let's see how many of you do it. Don't write some other code. I want to see this code only getting changed. Don't do it in thread 1. Do it in thread 2. It's the same code. We have given you the code. Change that code to produce foo bar 10 times. Code is not shared. Second, program thread 2. Open program thread 2. Is it coming? No. It's the same code. We have given you the code.
It's done, sir.
Okay, just check please. Program thread 2. We have given you the code. It's okay? Okay, good. So please edit that code to do this foo bar story. First thread should print, should have a shared object, foo bar. Instead of foo, call the shared object foo bar. First thread gets foo bar, second thread gets foo bar. First guy prints the thread on FB, foo bar object, calls foo 10 times. The other guy calls bar 10 times, but output I should always get is foo bar. Now the foo method does what? Print foo. Yeah? And bar method prints bar. And there the synchronization has to be managed. So foo will not print till flag is 1. Bar will not print till flag is 2. And it will make flag 1. And foo will make flag 2. Okay? If you are done, please let me know. Done. Fantastic. On program 2. Do it in program thread 2 so that I can see it here. Please do it under program thread 2 by altering our code. Just alter our code and try to do it. And once you are done, let me know. 57D. Okay. Okay, let's see your code. Looks good. Come down. Runnable. Very good. Yeah. Yeah. Bar. Yeah, I think looks okay. Okay, we'll go through one of your students' code. Okay. 570, same. Okay. So class foo bar, flag starts with 1. Yes, good. And the method is print foo. The print foo method waits till flag is 1. That means while flag is not equal to 1, it waits. It prints foo, then makes the flag equal to 2 and notifies any waiting bars that you wake up. Done. And of course, because of the interrupted exception, you have to catch it. Now, there is another method. Maybe you should call this print foo, print bar. Doesn't matter. Names don't matter. So, print second, it waits till flag has become 2. If flag is not equal to 2, it will wait. Then it prints bar and gives the handshake back to the first thread by making flag equal to 1. Flag is equal to 1 is a signal for the first thread. Flag equal to 2 is a signal for the second thread. So then this is the foo bar object. Then she has created 2 threads, which is already there in our code. This is the first runnable for the first thread, which very nicely takes the foo bar object as a parameter which will be created from main and prints or tries to print foo 10 times. But because of the synchronization, it will not print foo 10 times. It will print foo bar in that couple. So print foo, second implements runnable again, and this guy tries to print second, which is print bar 10 times. But again it will, because of the flags, it will work in a synchronized manner. Then we come to the main starts, creates 2 runnables, creates 2 threads from those runnables and starts them. They can be started in any order. It will come same answer. But let's see what answer we get. Okay, let's try. Let's run it and check. Yeah, okay. Yeah, I think one foo has gone under the telescope. So foo bar, you see nowhere has 2 foos come before a bar or 2 bars have come before a foo. Okay, that is the proof of the pudding. It has to come foo bar like that. That is synchronization. It should never, though we are printing in a loop 10 times foo, it will never print it because of the synchronization with the other thread. Correct? Beautiful code. Okay. So, anybody else finished? Okay. Now at least some of you should finished. Okay. Now we have, okay, I'll wait 2 more minutes. Let's do one more. Okay, slight variation. There are 3 threads, even, odd and 0. Even will print the next even number, odd will print the next odd number. Look at that question. It is 1116. Look at lead code 1116. Lead code 1116. Are you there? Yes? Read the question first. I'll explain. This is slightly smarter, but you can change the same code we gave you to do this also. See, there are 3 threads. It's how you manage your flag that is important. There are 3 threads. First thread prints 0 only. Second thread prints the next even number, whatever it is. It's earlier, whatever is the next even number. Okay? Then odd prints the next odd number, whatever it is, next odd number. Okay? How it should be called? 0, odd, 0, even, 0, odd. Always after every even or odd, 0 should be called. And then 0 will either call even or odd. It is, so first time flag will be 1. If flag is 1, next even, next odd. Flag is 2, next even. Okay. Flag is 0, 0. So after 1 is done, it should make flag 0. Now flag 0 should check whether the earlier flag is 1. No, yes. If the earlier flag was 1, what does it mean? That now it should call odd, even. If it was 1 earlier, it should call odd. I don't know whether you'll be able to manage it. Okay. You'll have to do a bit of thinking and then do it. So I will not want to do it right now. I think finish the first 2. Let me give you an easier one. Okay. This looks a little more management. You can do it. Only thing is, the flags have to be more carefully managed. Let me check if I have something easier. Okay, how about fizz buzz? Huh? Fizz buzz, multi-threaded. Okay, fizz buzz, fizz buzz. Acha, 4 threads. First thread prints fizz, then buzz. Third guy prints fizz buzz. And 4th thread prints a number. So, okay. So, if, that number is passed to everyone. Okay, this is doable. Can you make it bigger? Okay, there is a number which is shared. Okay. Because everybody needs to know the value of number. Okay, so that number is a shared variable, and okay, this is a good question to do. So, if the number is even, number is divisible by 3 and not by 5, it will print 3. It will print fizz. If it is divisible by 5 but not by 3, then it will print buzz. If it is divisible by both, it will print fizz buzz. And if it is not divisible by either, then it will print the number. No, yes. It's not that difficult. So, the condition should be the reason for waiting. So, here what will we do? The wait condition for wait. Right now we are using flag. Now we have to use these conditions. So, let's say you have a fizz buzz thread. What should the fizz buzz thread do? Wait till the number is divisible by 3 and by 5. Until the number is not divisible by 3 and 5 both, it should wait. Yes, no. And similarly, you will have conditions for fizz, buzz and number. Okay. The number should check whether the number is not divisible by 3 and not divisible by 5. Then it should print the number. Not very difficult to create. So instead of having a flag which is 1, 2 like that, the flag is a running number and every thread will increment, every method will increment that running number. Okay, so this is good to see. So see this. First time this number is not divisible by 1, 2. So then 3 is fizz. 4, buzz is buzz, divisible by 5. Okay, this is 3, this is 5. 6 divisible by 3 only, so fizz. 7 not divisible by 3, not divisible by 5. 8, no. 9 divisible by 3 but not by 5. 9 divisible by, this is 8, 9, 10. This is 10. Divisible by 10 but not by 3, so buzz. 11, neither. 12 by 3, so fizz. 13, 14. Now by 15, divisible by both, it is fizz buzz. Okay. You just need a flag variable which keeps incrementing instead of fixed 1, 2 like that. Yeah, you can make changes to our code. Do this after you have done, what was the earlier one? Foo bar. Yeah, anybody does this, please let me know. I would be, change our code only, don't write some other code. Change program thread 2 to write this code after you have done foo bar. This is a 4-thread solution. Yeah, by now you should be able to do it. It's easy. Only instead of flag 1, 2, 3, just have that condition. Till that condition comes, don't do anything. It's very, very similar to the earlier one. Instead of 3 threads, you have 4 threads. Take program thread 2 and change it. After that, I will show you how to change it. Program thread 2. You have to create 4 threads with that output. This should be the output. Each thread should wait for a particular condition. After it has done its work, it should increment. That's all. You know how to check divisibility in a while condition. Yeah, let us know as soon as you are done. Then do your work, that is increment the number and print your stuff. Or first print, then increment and notify. Okay. Anyone? 1116? No one. Do it for 15, doesn't matter. So at 15 it must stop, or maybe it should do till less than or equal to 15. Just have to write conditions correctly, that's all. While condition correctly. If you write the while condition correctly, that is enough. 4 different while conditions. Wait for that condition to happen. And the condition for 15 should be divisible by 3 and divisible by 5. The condition for fizz should be divisible by 3 and not divisible by 5. You have to write the not also correctly. And for everything, the first condition should be less than or equal to some value. Whatever, you take 15 as a value. Actually, that should be passed in the constructor as the maximum value n can take. Starting value should be 1. The starting value you can give in the shared object before you pass it to anyone. You initialize the object to 1 and pass it to the 4 threads. So the threads will examine that n and appropriately interact. Okay. Maybe I'll just give you a hint. Okay, maybe I think I'll give you a hint here. Think like this. Fizz buzz. Fizz buzz, no? Fizz buzz. Class fizz buzz. int n, we can say equal to 1 itself. Now the methods are print fizz. Okay. What should fizz do? 3, no? And not by 5. So while n less than or equal to 15 and n divisible by 3 equal 0 and n modulo 5 not equal to 0. If this condition is fulfilled, this is the condition for fizz. N should be less than or equal to 15. We have put this restriction. You can introduce this as a parameter also to the constructor and set it max value or something. So while n less than or equal to 15 and n modulo 3 equal 0, that is it's divisible by 3 and n is not divisible by 5, then what do? Then wait. No, we should write ulta. Okay, we should say not of this. No. N should be this and n, this is the condition and n modulo 5. Okay, this will be and not of this condition. This should go in bracket. Okay. And this condition should be fulfilled and this condition should not be fulfilled, which is n modulo 3 should be, you'll have to write this intelligently. Okay, let's try this. I think this is where we have, so if n is less than or equal to 15 and n, okay, we can write it reverse also. N, we'll write this easier way, n modulo 3 equal 0, okay, while, right? Sorry, while n less than or equal to 15 and, no, we shouldn't write while, sorry, we should write if n less than or equal to 15 and n modulo 3 equal 0 and n modulo 5 not equal to 0. If this condition is fulfilled, then what should I do? Then I should print SOP, I should say fizz. Okay. If this condition is fulfilled, I should print SOP fizz. I should say n equal to n plus 1 and I should notify. Okay. Now, if this condition is not fulfilled, I should wait. Okay, this is a slightly different code. If this condition is fulfilled, I should do this, else I must wait, because if this condition is not fulfilled, I'll do a wait condition, and this whole thing, because it has to run contiguously, I'll put, okay. Sorry, this is next, no? This one only. This whole thing I will put in while true or while 1. I will keep doing this. Now, if I find at the end of this condition, if n is greater than 15, I will do a break. Okay, I need a break. I don't need to do anything. So, slightly different loop. While true, continuous. If n greater than 15, break. If n less than or equal to 15, this may not be needed now. And n modulo 3 equal 0, n modulo 5 equal to 0, SOP fizz, n equal to n plus 1, notify. Notify the others after incrementing n. Okay, and if this condition, else you wait. If this condition is not fulfilled, I'll wait in the infinite loop. I'll wait here. Okay. This wait is important. So slightly different check and condition should give you the answer. You just have to be a little careful the way you write. And I have created a loop while true, n greater than 15 break. This is for fizz, please. You will have to write similar logic for buzz and for the number. If you can follow it, you can write it. If n greater than 15 break, because I don't want to run this thread after that. Then I check if n less than 15 and n modulo 3 equal 0 and n modulo 5 not equal to 0, I say SOP fizz. And I say n is equal to n plus 1 and I notify. Okay. Else means this condition is not true, then I wait. So even if this thread gets called again, what will happen is, for the next number, it will just wait. Okay, so this change if you do, I've given you the code. I mean, maybe because you have to write a slightly different code, you got lost. Okay. So this is, put this all in an infinite loop, n exceeds 15, break, will come out. Okay. Any variation of this will also work. Just have to be a little clever, little smart. Okay. All of you followed this? I've just changed the condition a little bit. Just understand, this is for fizz. For buzz, what will it be? Little alteration for buzz. The alteration will be, if n greater than 15 break, if n less than or equal to 15, modulo 5 equal 0, modulo 3 not equal to 0, then print buzz, only buzz, and whatever, same, print buzz, increment n, notify everyone, else wait, that thread will wait. Similar condition for fizz buzz, both should be equal to 0. And for just writing a number thread, none of them should be 0, not equal to 0 and not equal to 0. Okay, that's it. So then write that. Only clever thing we have done is there is a while true loop which will keep running these threads all over again till they either hit a wait state or finish. Okay. So we have to be clear when they have to wait and when they have to finish. So this is the synchronized method for fizz. Only thing is the logic will change for fizz buzz, and the number. So just adapt this code, finish 1116 on, you can finish it in lead code also now. Okay. In that, but don't copy from their existing stuff. Okay. So we'll stop here. Now in the next session, I am not sure whether You guys have got threads or not got threads? Okay, I think one more session on threads is needed so that most of you get threads, and then we'll continue. But please try and finish this, not very difficult.